In this demonstration, I'll show you how to find the definite integral using the fundamental theorem of calculus. This is part 3 of the series. Now, as discussed in part 1 and part 2, to find the definite integral, you need to find the antiderivative of the function. The antiderivative is denoted by these capital F's, and then evaluate those antiderivatives in between a and b, your lower and your upper limit. Let's get started with question 1. In question number 1, they want us to find the integral between 0 and 3 for the function square root of x times x plus 1. The best mode of action here is to expand and then find the antiderivative of those two terms. So what is the square root of x times x? Well, the square root of x is the same thing as saying x to the power of half. And if you multiply x to the power of half with x to the power of 1, well, you add these up. So you end up with x to the power of 1.5 or x to the power of 3 over 2. So we have x to the power of 3 over 2 plus x to the power of half. So that is our new, essentially, f at x. Now we need to find the antiderivative of both of these terms. We'll start with this one. To find the antiderivative of this term, you have to increase this by 1. Now if you increase it by 1, you end up with 5 over 2. X to the power of 5 over 2, and don't forget, whatever you find goes underneath. Now similarly, x to the power of half, you increase it by 1, you end up with 3 over 2. Plus x to the power of 3 over 2, and then we're going to take this and put it underneath. Now what you have to do is evaluate this at both 0 and 3. Now look at this. If I evaluate this term and this term at 0, they both go to 0. So there's no point of evaluating at 0. Let's just evaluate it at 3 and see what we get. If we evaluate it at 3, we end up with 2 times 3 to the power of 5 over 2 over 5. Now all I did was I readjusted this quotient so that you didn't have a fraction underneath. Essentially, I brought this 2 up and I left this 5 down there. Now don't be tempted to multiply these two. Remember, this 5 over 2 belongs to the 3 only, so they're not the same. Plus, now I'm going to evaluate this at 3 as well, and you end up with 2 times 3 to the power of 3 over 2 over 3. And that 3 belongs to that, and that is that. So that's your answer. I mean, there's no need to use your calculator. It is what it is. Let's move on to question 2. This question is tricky, so I'm just going to write down that it is not your typical type of fundamental theorem of calculus type question. They want us to evaluate the antiderivative between -1 and 1. So let's start off by finding the antiderivative of this, and I'm going to manipulate this so that it looks like x to the power of -2. So we're going to increase this by 1, and that gives us x to the power of -1, and that number will go underneath. So we end up with -1 over x. That's your antiderivative. Now we have to evaluate it at 1 and -1. So let's keep in mind the following, where that's your b and that's your a. With that said, let's start off with 1. If I put a 1 into here, I get -1, so that covers this part. And if I put a -1 into here, I end up with -1 over -1, which gives me +1. And so we have -1, and this was a +1, we end up with -2. How can you have a negative area? And it's a positive function, so how is that possible? Well, it turns out that if you were to graph this, and in fact, if you were to take the limit as well, you would notice that it is a discontinuous function. It actually looks like this on a graph, and it never, ever crosses the x is equal to 0. So therefore, the fundamental theorem of calculus does not apply for this situation. Let's proceed on to Q3. In question number 3, we have a discontinuous function. Essentially, they want us to find out the antiderivative between -1 and 2, but we have these two arguments that we need to keep in mind. Now they're saying that f of x, when x is less than 1, is 2x. So what we have to do is we have to find the integral between -1 and 1 for the function 2x, and then we have to find the integral between positive 1 and 2 because of this upper limit. And our function for this is 1 plus 1 over x. So now we have to find the antiderivative for this term, and this term. The derivative of this is 2x to the power of 2 over 2. The 2's cancel out, which give us x to the power of 2. And the derivative of 1 is x. And the derivative of 1 over x, if you look at your chart here, 1 over x becomes ln x. So let's write that down. This becomes ln absolute of x. So what we're going to do next is evaluate this between negative 1 and 1. Let's start with 1. If we put a 1 here, we end up with simply 1. And if we also put a negative 1, we also get a 1. So we have 1 minus 1 gives us 0. So now we have to evaluate this integral between 1 and 2. Let's start with 2. 2 minus ln 2, that's f at b, minus f at a will give us 1 minus ln 1. You can now put this in your calculator to find an answer, but most teachers will be content with that, and that's your final answer. So there you have it. 3 more examples on how to find the definite integral using the fundamental theorem of calculus. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.